This is Olympus Mons. It's the largest volcano in our entire solar system, and there are mysteries and questions that still surround this sleeping giant. How big is it? How was it made? Will Olympus Mons awaken one day? And why did such a gigantic volcano develop on a much smaller planet? Mars is about half the size of Earth in terms of diameter, but in terms of mass, Mars is actually about 11% that of Earth's and 15% in terms of volume. So how can it be that this massive volcano was able to grow on Mars? Towering nearly 13.6 miles high, it's more than 2.5 times the height of Mount Everest and stretches about 370 miles across. That's wider than the entire state of Arizona. This Martian giant is not only massive in scale, but also a window into the ancient geological forces that once shaped Mars. Its existence raises deep questions about how a planet smaller than Earth could host something so disproportionately huge. To understand Olympus Mons is to understand how different Mars is from Earth, and how it allowed this monster of a mountain to rise, erupt, and eventually fall silent. Olympus Mons was formed by the same basic process that creates volcanoes on Earth. Molten rock or magma pushed its way to the surface from beneath the planet's crust and erupted, building layer upon layer of cooled lava over time. But while Earth's volcanoes tend to be relatively modest in size, Olympus Mons grew to mind-boggling proportions. One of the key reasons lies in Mars's lack of tectonic plate movement. On Earth, the crust is broken into plates that constantly shift and slide over the mantle. That movement prevents most volcanoes from growing too large because the hotspot that supplies magma moves around with the plate. Hawaii is the perfect example. It formed as a chain of islands as the Pacific plate slowly drifted over a stationary hotspot, creating multiple volcanoes instead of allowing a single giant one to grow forever. Mars doesn't have active plate tectonics. Its crust is more or less stationary, which means the volcanic hotspot that powered Olympus Mons stayed in the same place for millions, even billions of years, if it even moved at all. This allowed the lava to build up in one spot without being broken apart or relocated, creating a single towering shield volcano. Layer after layer of basaltic lava flowed and hardened, spreading across the Martian surface with little resistance due to the planet's weaker gravity, which is about 38% that of Earth's. That weaker gravity allowed the lava to travel farther and pile higher without collapsing under its own weight. Over time, Olympus Mons grew into a gentle-sloped, monstrous structure with sides so broad and gradual that from the ground, you might not even realize you were standing on a volcano at all. The age of Olympus Mons is ancient. Its earliest eruptions likely began over 3.5 billion years ago, during Mars's Noachian period, when the planet was much more geologically active. Most of the volcano's bulk, however, was probably formed during the Hesperian period, between 2 and 3 billion years ago, when volcanic activity on Mars was still common. Some of the youngest lava flows on Olympus Mons suggest that it might have been active as recently as 50 to 100 million years ago, very recent in geological terms. That means it's possible that Olympus Mons isn't entirely extinct, but rather dormant, sleeping under the cold, quiet skies of Mars, awaiting another spark of internal heat. Today, Olympus Mons appears frozen in time. Its massive caldera, a collapsed crater at the summit that formed when the magma chamber emptied and the top caved in, is surrounded by smaller collapse pits and concentric rings, a sign of multiple eruption phases. Its flanks are marked by immense lava flows that hardened into plateaus and by landslides that fell away from its edges, giving clues about its structural weaknesses. The base of the volcano features a dramatic escarpment, steep cliffs up to 6 kilometers high that formed where the lava cooled abruptly against the surrounding terrain. This may be the result of ancient lava meeting icy ground or even shallow seas, hinting that water may have once existed nearby. What's left now is a massive geological monument showcasing the planet's fiery past. It rises so high that its summit pokes into the upper atmosphere of Mars, where the air is so thin that the weak and sparse winds barely erode its surface. That's one reason why its features remain so well preserved. Unlike on Earth, where weather, rain, and tectonic forces reshape mountains constantly, Mars is largely static. The volcanoes' lava fields, caldera rims, and surrounding landslides are ancient but eerily intact, as though they solidified only recently. Olympus Mons also tells us something about the internal cooling of Mars. While Earth's hot interior still churns with activity, creating earthquakes, volcanoes, and mountain ranges, Mars has largely cooled and gone quiet. The volcano's silence today is part of a planet-wide geological sleep. Its death wasn't explosive or dramatic. It was more of a slow fade. As Mars's interior lost heat over billions of years, the magma chambers feeding Olympus Mons emptied and hardened. No new lava reached the surface. The eruptions stopped and the mountain froze. Despite being dead or dormant, Olympus Mons remains a subject of fascination. It raises tantalizing possibilities about the planet's inner workings. If Olympus Mons were to ever wake up again, it would be an event of planetary significance. But for now, it stands as a silent sentinel, a relic of a much more violent and dynamic Mars that once roared with fire. I'd like to thank you for exploring the volcanic giant Olympus Mons and invite you back for our next episode of A Godless Universe.